Okay, the next section of today's class is terms used in wave or wave terms. Number one, we have amplitude. Two, wavelength. Three, crest and trough. Four, compression and rarefaction. Five, wave front. Six, frequency. Seven, period. While eight, wave velocity. Now, what is amplitude? Amplitude means maximum displacement. Amplitude means maximum displacement of particles from rest. So the maximum displacement is known as amplitude. Now, if you look at this waveform, you find out that all the particles, they are moving like this. They are moving upward and then they come down. Now, if you look at this particle 1, this particle 2, 3, 4, 5, 6, 7, 8. Now, if you look at this diagram very well, you find out that this point here is known as the particle here is not moving. The particle is at rest. Then if the second particle move upward a little bit, then the third move upward. Then while the fourth move to a higher distance compared to the rest. So this point here is known as the maximum displacement. This point is known as the maximum displacement, which is known as what? The amplitude. So this point in this waveform is known as amplitude. Amplitude means maximum, the highest, because all of them, they all displaced. They all displaced. All the particles, they all displaced from rest. So the one that have the highest, or the one that have the maximum displacement from rest, is known as what? Amplitude. So this point in this waveform is known as amplitude. Then, before I talk about wavelength, I need to tell you guys the meaning of crest and trough. Now, crest means upward. Crest means upward displacement. Crest means upward displacement, while trough means what? Okay, you can say crest means maximum upward displacement. That is the meaning of crest. Whereas trough is what? Maximum downward displacement. So this part is known as crest, this part is known as trough, this part is known as crest, this one is known as trough, this part is known as crest. So crest, trough, crest. So crest means maximum upward displacement, while trough means what? Maximum downward displacement. Now, what is wavelength? Wavelength is just the distance. Please take note of all this. Wavelength is just the distance between two crests, or the distance between two trough. Okay, that is the meaning of wavelength, and the symbol of wavelength is lambda. So this is the symbol of wavelength. Take note that wavelength is measured in what? In meter. This is symbol of wavelength. Okay. Then crest and trough, they are specifically used for transverse wave. Crest and trough, they are specifically used for transverse wave, whereas compression and rarefaction, they are used for longitudinal wave. Compression and rarefaction is specifically used for longitudinal wave. Now, from the word compression, these two are longitudinal wave. This part is known as compression. This part is known as compression. Where this part is known as rarefaction. This part is known as rarefaction. Then this part is compression, rarefaction, compression, rarefaction, compression. A point where there is higher density of air. This wave is specifically for sound wave. A part where there is high density, that is known as compression, while the part where there is lower density of air is known as rarefaction. So compression, rarefaction, compression, rarefaction, compression. Same goes for this place. Okay. Yes. So that compression and rarefaction is specifically used for longitudinal wave. Then where is a wavefront? Please take note of this definition. It's a Jamb question. Now, a wavefront is a line. Take note, a wavefront is a line in an advancing wave. A line in an advancing wave in which all the particles are vibrating at the same phase. So Wavelength is a line in an advancing wave. Please take note of this definition, okay? Then move to frequency, period, and what? Wave velocity. Move to frequency, period, and velocity. I can remember that in our previous class, I told you guys the meaning of frequency and period. I also give you guys the formula, okay? Now, what is frequency? Frequency just means the number of cycle made in 1 second. If they say a wave made 2 cycle, now how can you use this to tell the number of cycle? This waveform, how many number of cycle does this wave that I just draw have? Now let's calculate it. This one is half a cycle. Remember, this is a cycle, abi? So this part is similar to this. Then while this other part is also half of a cycle. So this part is similar to, okay, this part is similar to this. So this waveform, as this is 1 cycle, then this is what? 2 cycle. So this waveform has how many cycle? It has 2 cycle. If I remove this part, it will have what? 1 cycle. Okay, so frequency is number of what? Is the number of cycle. It's number of cycle made in 1 second. Okay, so for example, let's say I bring a waveform like this. This waveform, let me calculate the number of cycle. 1, then 2, then 3. It has 3 cycles. So the meaning of frequency is just the number of cycle made made in 1 second. So you can say number of cycle per unit seconds. That is the meaning of frequency. The SI unit for frequency is Hertz. This is short form. So Hertz. The SI unit of frequency is Hertz, and this is the short form. So this is the SI unit for frequency. Then period. What is the meaning of period? Period is opposite of frequency. Yeah, period is opposite of frequency. Period is the time. Period is the time it takes to make one complete cycle, or you can say the time it takes to make a complete cycle. Period is opposite of frequency. It is inverse of frequency. If frequency is the number of cycle over time, period will be what? Time over number of cycle. Since both of these two, they are inverse. If you look at frequency, n over t. If you look at period, you see t over n. That's to tell you that frequency is inverse of period, or period is inverse of frequency. I just placed 4 formula in the board. Formula of frequency is F equals to n over t, or F equals to 1 over period. Okay, while formula for period is time over n, or time equals to, or 1 over frequency. So this is to the major difference between frequency and period. Okay, so in a transverse wave form, in a transverse wave form, this line here is stand for the time. This line here stand for what? The time. So that is the time. Time is the SR6. This line here stand for the time, while this stand for what? The number of cycle. Okay, so then we move to wave velocity. Now, what is wave velocity? What is the meaning of velocity? You can say wave velocity is equals to, okay, the formula for wave velocity. Formula of wave velocity is equals to is equals to wavelength times frequency. So this is the formula for wave velocity, equals to wavelength times frequency. This is the formula for wave velocity. Remember, lambda is the symbol for wavelength, while this is what? Frequency. So wave velocity is equals to V equals to wavelength times frequency. Okay, this is the waveform of transverse wave. Now I want to teach you guys how to calculate for frequency and period whenever you are given question like this. If you guys can recall, I told you guys that this is a transverse waveform. Okay, now this This is the x-axis. This x-axis stand for what? The time. Please, this time is not the same as what? It's not the same as the period. Okay, the x-axis is the time, while the y-axis is what? The displacement. Whereas all these things you see here, they stand for the number of cycle. Now, in some particular question, they can just give you, they say, okay, they'll give you this waveform. They'll say, calculate for the frequency in this waveform. It's very easy. Remember, frequency is equals to number of cycle over time. Okay, so they can tell you to calculate for the frequency in this whole waveform. Remember, this x-axis stand for what? The time. Please, it is not the same as the period. Period and time, they are the same thing, but in here, this period is different from this time. Okay, so this x-axis is not the period. Okay, so in this, let's say we should calculate for the frequency of this whole waveform. How are you going to do it? At first, we look for number of cycle. Okay, so let's start. This first one, this is what? One cycle. Remember, here is half, then this other place is half. Adding it together will give you what? One full cycle. Okay, so this place is what? In, let's calculate one. This is one cycle. Then here, two cycle. While here is what? Half cycle. So everything, the number of cycle here will be what? 2.5, which is 2.5 cycle. Then the number of the time. Now the time in which we made the 2.5 cycle is what? 10 seconds. So the time will be what? 10. I don't know if you understand. 2.5 going to 10 give us the frequency will be 0.25 Hz. Frequency will be equal to 0.25 Hz. Now, if we are to calculate for the frequency in the first cycle, it's just easy. F equals to N over T. So the very first cycle, this is 4 seconds, this is 6 seconds, this is 8 seconds, while this is 10 seconds. So if we want to calculate for the frequency in just these two parts, in just this part, it will just be the number of cycle. The number of cycle is 1. So while the time in which you make that one cycle land at where? 4 seconds. So now be 1 over 4. Okay, which is something as what? 0.25. Okay, yes. If we are to calculate for the frequency in this place, we need to count the number of cycle at first, because F equals to N over T. So this is one cycle, this is what? 2 cycles. Now be 2 over, now the time it makes the 2 cycle is what? 8. So everything now be 2 year 1, 2 year 4. Our answer will be 0.25 Hz. So if they ask you, if they give a waveform, if you find out that in any way we calculate, in any number of cycle we use, we also get the same answer. We also get the same frequency answer. If we just calculate from year to year, we calculate for a number of cycle. If we calculate for a frequency from just these two places, we get the same answer. If we calculate from year to year, we also get the same answer. If we calculate from year to year, we get the same answer. Okay, so let me all try here. Now, frequency equals to number of cycle over time. Now, here it makes a half cycle in what? In 2 seconds. So it will be what? Half is what? Half is 0.5. Okay, so 0.5 going to 2 will give us 0.25. Okay, so this is how to solve questions when they give you, when this is how to solve this type of question. Now, if they tell you to calculate for the period, it is very easy. Remember, period is what? Time over number of cycle. Is very easy. So the time, let's say we use 10 now. 10, then the number of cycle we made in that 10 seconds is what? 1, 2, 2.5. So 10 going to 2.5, you have your answer. So that is how you calculate for period in this type of question and frequency in this type of question.